Okay. Okay, hello everyone, and welcome to our March WMISA seminar. Before we get started, I would like to acknowledge the people of the Kulin Nations on whose land I am today. I pay my respects to their elders, past, present, and emerging. Indigenous Australians are the oldest continuous culture and have studied and understood the Australian land and environment for more than 50,000 years. They were the first Australian earth and environmental scientists. So the WMISA seminar series is about showcasing the amazing work of women in earth and environmental science in Australasia. As well as the live seminars, we also have collated recordings from seminars that are hosted by other organisations, and we've made and they're available online, and we've put those on our website and on our YouTube channel. The live series is on the first Wednesday of every month. So the next one will be April 7. You can sign up as a member of WMISA to get a notification of the seminar, or you can follow us on Twitter. But now onto today's seminar. So Graciela Metternicht is a professor of environmental geography at the Earth Science and Sustainability Research Centre of the University of New South Wales. She's an environmental geographer who works at the interface of science and policy for sustainable development. Graciela has been instrumental in the development of the conceptual framework for land degradation neutrality, implemented in 122 countries and central to the UN Sustainable Development Goal of life on land. She currently advises on matters of land degradation for the UN Global Environmental Facility and chairs the National Committee for the Geographical Sciences of the Australian Academy of Sciences. Okay, so without further ado, I'll hand over to you, Graciela.
Thank you. And before starting, I also like to acknowledge this presentation I'm doing is from the Gadigal land of the Eora Nation, and I pay my respects to past, present, and future elders. I am honored and thank you very much, Melanie, for this invitation to share this this project, one of the projects I'm doing at present. And I was thinking as I was preparing, you know, what to talk, what not to talk. And I thought I will give the background of this project. And I think one of the things I'd like to do today, beyond going to the very technical details of Earth observation and all the technologies and the algorithms we are doing, I like to focus on two aspects, one being the importance of not only developing research, but also how we can improve the level of uptake. And in there, I will refer to the work that we have been doing around having an early engagement with stakeholders. And more towards the end, I would like also to open one last slide on the learnings that we have had through this project that has been now underway 1 year, and my own learnings and reflections also on what I think could be another point for debate within the seminar at the end around the issues of implementation science and translational research. So without further ado, what is this COALA thing that you see here? It's an acronym that whenever there are projects at the beginning, we always try to think on something that can define the project by a name. And this was developed by our colleagues in Italy when we began writing this application. And COALA stands for Copernicus Applications and Services for Low Impact Agriculture in Australia. So this is what I'm going to talk today. This project is funded, as I think I say in the title, by Horizon 2020. Horizon 2020 is one of the fundings that the European community provides for innovation in research. It did have a cycle of 7 years that it finished last year in 2020, investing more than $80 billion to foster research and knowledge in the European Union. However, some of the programs did have an aim of trying to reach out some of the good technology and the good knowledge from Europe out to other areas. And it's under that little branch of the Horizon 2020 that there was a call for cooperation between Australia and European researchers, and we did apply. What is Copernicus? For some of you might be a new name. Copernicus is one of the missions, is funded again by the European community, and is an Earth observation satellite mission that is run by the European Space Agency, and it has a constellation of satellites called Sentinels, amongst others, and the ones called Sentinels are the ones that we are using in this research. And this is open access data sets. So what when I said, well, what this project is about, our big aim when we start was that we use those satellites from the Copernicus mission, and that we try to share the experience and the expertise of European researchers and small medium enterprises that they have developed on Earth observation-based applications for agriculture with Australian institutions. The idea is that how that research that has been developed could be adapted and transferred to the Australian environment to help some of the areas of Australia that are working around sustainable agriculture and sustainable water use. And also another of the aims of this program is try to foster the creation of startups and new businesses. So who we are. Therefore, when we began with this project, which is a consortium of 11 partners, and some of these partners are European community-based small medium enterprise. We have one in Italy, one in Spain, and one in Belgium. They are working on how to promote the uptake of technology based on Earth observation within the Spanish and the Italian environmental management areas. Then we had our academic partners, which is University of Melbourne in Australia, University of New South Wales, and one university in Spain, University of Castilla-La Mancha, and one university in Austria. We have end users from the European community that are already communities or cooperatives of farmers that are already adopting the products that we try now to transfer to Australia, and they are the ones that can provide the, what an end user needs or why an end users would be prepared to uptake this technology. And then we have two business partners from Australia, which are Rubicon, that works on the area of efficiency in irrigation management within the Murray-Darling Basin, and the Birchit group, that is an agricultural consultancy group working mostly on rain-fed agricultural areas within the Murray-Darling Basin. So with that, those 11 partners, we also are bringing in this a prior experience of the small medium enterprises from Europe, and this is something that the European Union, when they fund this kind of projects, look for how to build up some from previous projects, how the knowledge they have invested in keeps building up. And this is a list of the projects that they did fund, which for some of our partners in the past. So what we want to do is exploit better the capabilities of these Copernicus programs of satellites. We know that over the last decade, there has been explosion of data sets, whether this is from Earth observation, whether it is from other kind of non-imaging sensors. We also are working or intend to work with information that might be provided by drones, but airborne. And the question is how you integrate all that information and you make that information then available to the users. So using that technology from Earth observation satellites that is repetitive, that we know covers certain parts of the electromagnetic spectrum that we use to produce the images that then feed into the information and data that we need. We also are relying in another area of investment of the European Union, which is around cloud computing. There is an information access, data and information access service called DIAS that the European Union did fund, and they promote the use of that platform as an interface to reach out to establishers or to the end users, whether those end users belong to the research community or are working in the interface of government agencies and so on. So this is another aspect. So to promote the concept of also what we call the data and information service and data and data ready services. So that's these are the other aspects of the projects that we will try or we try to embed into all what we are doing. So what we intend also is to work with application program interfaces so that at the end of the day, whatever the project produces as a product or as a service is built up into existing platforms, not to create new platforms. And that's why we one of the requirements was that we had business partners within Australia. So our business partners already have platforms that they use to deliver the services to their end users or clients, being farmers mostly. So the idea is that we work with them so that whatever we produce can be readily used and taken up through their platforms rather than inventing a new platform that sometimes then die after once the project funding is over. So this is the other part that we try to embed into this project. So how the project works. So this is the cloud computing that we have here. We use Earth observation data that then we match with other local data sets. For instance, the University of Melbourne, they own airbornes, they own drones, and those are going to be used to validate some of the and calibrate some of the algorithms and the products that we will be producing with the use of Earth observation. Then there are other types of data that are not derived from Earth observation, but which are needed to create the products and services that farmers do need. And say they might be coming from the Australian Bureau of Meteorology. They might be field collected data, like for instance, soil properties that are, say, a point location. So all that data sets then are integrated and try to package, which is what follows now in my talk, is try to package around the concept of business to business users. So what our small medium enterprise see as an advantage, see as something that they could also promote within their current businesses to improve the businesses of farmers. And then with that in mind, then is the idea that we would develop the final set or tailor the information that we derive from all of the above here, so that it can be of use to basin authorities, can be of use to water managers and to farmers. So this is an example, say, we develop within our COALA project, our APIs, but then those would be we would work with, in this case, IlProfit, that is a platform that belongs to BCG, or with Farm Connect, which is a platform that belongs to our other partner, Rubicon, so that all these algorithms, nice images that we create from the Sentinel satellites can be part and can enhance the business proposition of these two partners that are part of our project. This is a kind of whole picture in terms of how we have decided to manage the project. We have constructed 7 working packages So every package would have it has a leader. We have collaboration between the different packages, and how, for instance, what I wanted to illustrate in this picture is the value that we are not only after creating new algorithms and new images and whatnot in terms of services that can be derived from Earth observation, but also what the users require, and for that and how the users requires and dictates a bit of what we end up producing, and then that we apply over pilot areas that we have pre-selected within the Murray-Darling Basin. And the idea is that then we use what the commonly known user-driven approach. So this is a bit of the big picture about the project and the structure that we try to follow. This project is to be delivered within 3 years. We are in year 1, so we still have 2 years to go. And the question that some of you might ask, why Australia? When they were looking for partners, they saw that Australia is a market that is quite mature in terms of uptake of new technology. We have many young Australians that are in the agricultural sector that are smart in terms of uptaking and giving a go to new technology, and also the size. So we working with Earth observation satellite, the issue of size is one that is important to us. So the size of the paddocks make it easier to adopt some of these Earth observation-based technologies. So as I said before, we have chosen farms and as pilots within the Murray-Darling Basin for the issues that we know. The issues around conflicts with water use, issues around water efficiency, large proportions that are devoted to irrigation, being the food bowl of Australia, and other areas that are more rain-fed within the Murray-Darling Basin. This is the list in a kind of matrix to illustrate you that we work with 3 different sets of Earth observation-based services. Some of them are around services to manage better water and to try to help in the way water is allocated. Other services are more oriented to rain-fed agriculture, which are around the better management of nutrients in the soils, and this service that is around crop yield estimation and crop developments through the growing season. Now, within those, when we began building the project, we did identify what we call 3 main segments. One is the segment of farmers as a users, the other is the segment of water management or irrigation infrastructure, irrigation operators, and the other is we kept thinking how all these products could also help basin authorities in relation to water compliance issues. So these 3 big segments do intersect with the kind of services that we have in mind to produce. So with the help of the University of Melbourne and our business partners in Australia, there was a selection of pilot areas where we would demonstrate, try it out and demonstrate the products, engage with some farmers, our champion farmers, to work and derive products and assess whether the products are viable at farm scale and at the district scale. And we selected this map with 4 areas, so all distributed. Some of them are more or less, perhaps less advanced in terms of techniques around irrigation infrastructure. Others are more advanced, and then we have the mix between farm scale and district scale. So the other thing I wanted to touch is that one of, developing as researchers, at least in the area of technology, we tend to think, okay, we have the funding to do research, here we go, we will develop these algorithms, and then sort of sometimes aftermath, we begin thinking, okay, what is really what the the stakeholders or the potential users actually want from us, and what we can produce, and whether we can marry that wish list with whatever we are able to produce. So I think here there are three aspects that we did focus. One was to engage with the users from day one. The second was trying to understand what they really wanted. And the third one is to have ourselves an understanding of the challenges, and also to be able to communicate to some of the users that some of the desires or the wish list they have is not possible to be derived, at least from the data sets that we might have at present under the frame of this project. So for instance, one of the things we did as a group, particularly for our European colleagues, was to do a desktop review to understand what are the issues around water management and scarcity, because if we want to influence the uptake of this technology for management and hopefully for better policy, we need to understand how water is allocated, for instance. For our colleagues that were working more in the part of algorithms, some basic concepts as what is the meaning of a water entitlement, water allocation, water usage, how it happens, what happens when a farmer is allocated X amount of water and then they use more or they use less. So how all that trading exists, the basics of these things. So how the market is created, and then also what influences on the dynamics of that market, and also understand the different actors around the governance of water management and compliance. And in there, for instance, we identified the Murray-Darling Basin Authority, we have members that do sit in our advisory panel, and the importance of understanding irrigation infrastructure operators and the rules they have and what they have in place and what they might need. So we did engage early on with our user community. We conducted a stakeholder analysis. I'm trying to remember how many we had. A total of 53 stakeholders that were interviewed. Mind you, all this, as we began rolling the project, I will refer, we were working on last year under COVID. So, all the lockdown, no travel. So many things that were planned from the beginning to be done in the field through interviews face-to-face had to be replaced by telephone interviews, by virtual focus groups. And that's the way we have been operating. So we began to first understand who were our, to identify, to profile our potential users under these three main segments that we did identify. We did build up this kind of stakeholder maps to understand the connection between the different users, and therefore once we had that, we could then identify some of our champions. Go down. Okay, so after conducting these 43 stakeholders interviews with representatives from the different groups, things that came clear for us were that farmers do want critical information at the right moment, and often that tends to be real time, which represents for Earth observation derived, Earth observation derived information that sometimes might represent a challenge because it means some hours of delay. Is not an immediate access. They want things that are easy to use, integration of information and data from different resources, from different sources, and weather forecasts, whether that was possible. So this is the wish list that we were put from our interviews. We also tried to understand what were the end user challenges, and we did have like 4 cases. One was around water management. So what were their issues with water management? What were the main issues around nutrient management? Remember, I say these are our 2 main clusters of products and services that we aim to produce. And then what are the issues around information sources? So how people prefer to access information, what kind of information they need. And also we also have information needs around things that they would like to have, better irrigation scheduling, or whether that is the rainfall forecast or nitrogen use efficiency. And we also identified some of the issues, and I highlighted here some that I think were important for us, which is around the information deluge. So the fact that many times farmers and end users get just overwhelmed by the amount of companies offering different services and products. So this I don't know what is better, on how are you different from the others that are working in similar space. The need of translating data into decision making, the trust that farmers and other users do have or not in satellite images and what they can do for them, and how to interpret new information that is being produced. And I put here some of the statements that we collected from farmers, that some of them were saying, well, costs might be prohibitive. We are really looking into analyzing the water markets, and this is what makes all the basis for our decision making. Another that says we have a lot of data out there that we don't use, and I will be honest, we need to start just like figuring out what they can do for us. So it's not a lack of data, it's sometimes how you do use that. So once we have all that, scene set in terms of needs, in terms of challenges, we began a process of co-creation jointly with our two small medium enterprises. That process of co-creation is coming from experience of our small medium enterprise from Europe. They have used it a lot in Spain, and it consists on working on identifying a champion that we did in this case with BCG to begin developing their needs and matching, as I say here, matching what is wanted with what is possible. And that's the process of co-creation of the blueprint, where we began highlighting what are the successful experiences in Europe for them to see whether, okay, this could work for us, this is something of what we need, or they might say to us, no, this is completely unnecessary in the environment we work, and we don't see any value of information. So that this is a process that is ongoing. With some of the champions, and we access information from these paddocks, and the teams of Italy, Austria, and Spain began developing products for their farms that at present are being validated. And you know, the issue is how these things that have been developed in Europe work here. So the process of validation and calibration using even airborne information and in situ field data sets is what we are focusing in this second year of the project. So what we are now is in the stage of, we understood the user requirements. Now, what are the technical requirements? What are the technical specifications? What data sets our products can have in, what data sets are needed, what the end user needs, but also what is the frequency that we can produce these data sets. And here is an example of the products that we offer and how our end users are seeing whether they really need that this is daily, weekly, monthly, once a season, that can be downloaded, that can be displayed. So I put here what we really aim to have at the end. And the idea is not only pure research, but this is really a project on applied research, and then hopefully is that to create these sustainable supply chains and bring a new aspect of innovation for the applications of Earth observation. To work with customers and existing businesses so that you don't reinvent the wheel, but you strengthen what is already there so that your B2B users can improve their services using this open access data from Copernicus. And lastly, that the experience that we have created through this project could be transferred to other areas around the world if we succeed in what we are aiming to do. So I want to conclude with what I think have been learnings so far. At least I kept thinking this morning what could be 5 or 6 key learnings. One has been the complexity of the consortium. So it's usually we had partners that we have worked with before, but many of the partners that we began working in this venture is the first time we are working together. So as I put the picture here, we all began nicely in February 2020 with a 3 days meeting in Naples, face-to-face, excellent discussion, and then COVID hit. Our partners were expected to come to Australia to work with us, visiting the farms, understanding the business, understanding the context. Nothing of that happened. So we have conducted all a series of our meetings and the project planning and deliverables through Zoom over the last year and our very first plenary meeting. So that also tells me about that collaboration usually is something that we are used to in academia. Now the cooperation, particularly under the new COVID era, and when we have partners in different continents, can be a bit challenging. Having some of our experts that would have come here help us running our stakeholder engagement workshops and transferring that experience and talking through to farmers, that could not happen. So it made an extra burden on some of our Australian partners and the difficulties to run parallel processes where the delivery of one product was feeding into the progress of another one. I will leave this one for the last. The fourth one for me was the communication and dissemination. Usually it's an aftermath of the project. This time we thought that we want to build, or it's a component that the project really the European Union do ask for a strategic plan on communication. And it goes beyond the paperwork for the, say, beyond preparing papers for conference or what academics we usually do. So we began from year one, and we are working with a journalist, and we are working with an expert in science communication, and that has, to my surprise, it has proved to be really a plus in terms of engagement. And most of all, we began working with curriculum developers of a high school. And this is the legacy component. One of our experts in communication said, it would be nice that you think on building legacy through educating or through putting open access resources for high schools. So we could find that connection with the Department of Education of New South Wales, and we told what our data sets are about, and they were elated that they could use that to use or to make the year 10 and 11s in agricultural schools experience what it's like using satellites for farming applications. And that has been going quite well so far. So I put here COALA projects for schools. And it's about teaching in high schools the potential of satellites. And the other thing for me was in earth science, I'm particularly working in the field I am working on Earth observation satellites. for us was to demonstrate how are we different from the others? What is that we are bringing here that is going to be different that many other providers are not already delivering. And the last one for me is that concept of translational research. How within academia usually perhaps we don't have the ways to the key performance indicators for us to devote more time to work in translational research and in implementation of applied research. We sort of work on what some people say this supply model, where we do the research, we write up the papers, and then by some magic we hope that managers and policymakers are going to notice about our projects and that are going to uptake our wonderful ideas. But this doesn't happen. So is that constant dilemma, I think, for many academics, that you don't have key performance indicators that put on the time that you put to write a blog, or to, I don't know, to engage with a community farmers, or to engage with a high school to go and give your talk, which are things that can build or help to connect your research findings with those that are in charge of management, or those that are in charge of policy. I think that the environment is changing, but pretty much I think in many areas, at least within the earth science, we still continue with our oil supply driven model, and our focus is really on writing up the grants, getting the grants, doing the research, publishing, going to the conferences, having our PhD students, and then if that all works, our projects are very successful. So with this, I like to conclude. I put here the list of all our 11 partners and some of the people that are really leading the technical development of the product we are using. And this is the front page of our website that we have been, we are trying to constantly feed and keep updated. And thank you very much for your attention. And I hope that this talk is of your interest.
Thank you so much. That was a wonderful talk. I learned a lot. It's not within my field, but that was really excellent. So we'll go now to questions, and people can ask those via the chat, or you can unmute yourselves and turn on your video and ask a question there if you like. And while we're waiting for people to organise themselves, I've just got one question. So I was wondering about what you think the greatest benefit would be for Australian farmers. And it seems like there's lots of benefits listed there, but I was wondering what you think that they'll find the most useful.
I think the most useful it would be if there is a learning and uptake for some of the products, at least around what I'm seeing now is around the better management of nutrients, or say around the concepts that go with precision farming, and this we have management zone maps. So simple things that could tell about variable rate applications and about better or more efficient use of fertilizers, for instance, so that you don't overuse, you save money, but also you don't pollute as much. So I think for me, this would be one of the things. And the other is having the next generation of farmers, of young farmers, that will have to struggle much more than this one in terms of climate change and the more extreme events, how they can think ahead and be smart and be supported by this kind of technology. And that's a process that takes time for learning. And that's why I think the aspect of legacy, the aspect of connecting with education, that unfortunately doesn't count much as a brownie point in our research projects, but I think it's important.
Yeah, absolutely. Joanna, did you have a question?
Yeah. It kind of follows on from what you were saying, Melanie. And I just wondered, fantastic talk, Graciela. I really, really enjoyed it. I just wondered, have you a feel for the appetite for change from the farmers? And also, are you considering working with the agricultural researchers to use your products in predictive things that they can use, that the farmers can then use, you know, not this year, but for predicting seasons next year or in the next 5-year cycle?
Yes, for the fair, we are open to work with whoever is interested. So if you know of any that could be interested, please by all means get us connected, because I think one of the things we are struggling now is into getting that trust and getting that, as you say, that appetite for what it can do. You say about the appetite for this kind of products. I think is growing, is changing, and this is one of the things that our European, and when we began developing the project proposal, they highlighted that in Australia farmers are more like risky or ready to dare to change. And I have seen this. We have been having this kind of co-creation processes, and last week, for instance, and we were saying, look, this is the map, and then the farmer was saying, look, this is the picture of how I have been doing it. And my colleagues were saying, if we give you the maps ready that you put in your smartphone, are you ready to give it? Oh, yes, of course, I'm ready. So in that regard, once you engage, they are not afraid, or they don't mind to give it a go. So I think there is a bit of an appetite there, and at least this neutral attitude as to I don't mind. Whether the appetite is there that I will pay for that, and we know that that might be more difficult, because this is the other discussion we have been having. So say, if this works, are you prepared to pay for that, and how much are you prepared to pay for that? So this is something that I think goes more with the businesses in terms of then seeing the value for money and what I'm delivering, and I think it's stable. Sometimes it goes around, perhaps around cycles of if there is no need, people will say, well, I have been doing business as usual, so my business go well, why should I? But as I was saying to Melanie, I think things are changing, and when people see that a drought is no longer, one in a 50 years now, we are going to have more of those. Once you see that some of the incentives from the government might dry away, once you see that your land is not as productive as it used to be to your grandparents because you're a 5th generation farmer, then I think that might be the other incentive for appetite. And the other is, perhaps that's another discussion that we had, is that not always you need to reach directly to the farmer, but your best ally might be the advisor to the farmer. So you work with these federations or the cooperatives or the communities. Right. And once you have a champion there, sometimes it's easier to sort of change perceptions, change worldviews that they might have established, because I was saying to you before, the trust about the satellite images. Some, for instance, there is one product called the Normalized Difference Vegetation Index that is very popular. So this is the one that they have seen told to them a lot. And one farmer was saying to us, well, for me, for my canola, that thing did nothing. And my colleagues say, well, okay, can I give? And he was showing to him and explaining, look, this happened because of this, and we observe these other things. So sometimes it's also they might have had one bad experience, and that is more than enough to just shoot the window, and they don't want to hear anything else.
Yeah. Oh. Incredible.
Excellent. Well, not excellent, but yes, it was a good explanation. Were there any other questions from anyone?
Maybe we could drop some kind of email to
send out. Yeah, hi, I have a question, please. Thank you for this inspiring presentation. You said you want to see if you can be different than others. How you do things differently? Can you be more specific? What products are you working? What problems are you solving? And if you can provide a bit more technical detail, not staying in the high level, that would be great. Thank you.
Yeah, no, Yuval, I was saying at the beginning, my talk is very general, so I can provide in the chat my email, so you write me there and I connect you with the technical people that are doing all the algorithms, and you can even access our website to see the products that we are offering. That question that you did is the first one that came to us. So if so-and-so is doing this, and it's exactly the same that you're doing. So I think what we are doing different is perhaps the issue of access, rapid access to satellite data. Through the DIAS platform, the time of access to process data sets and the algorithms that we have applied is much reduced. And what my colleagues have told me is that because the data sets now can be ready in 2 or 3 days, then, for instance, things such as forecasting of the amount of or the volume of water can be reduced, and that could be an advantage. I think the product per se, there are other many similar because management zone maps are not new. There are people that have been producing them in the past using Landsat satellite data, but then again, the pixel resolution is larger. So in this case, we use Sentinel, so the resolution of the products will be larger. So means that you might work with that 10 by 10 pixel, 10 by 10 meters pixel size, or 20 by 20, while with the Landsat, similar products were produced in the past as 30 by 30. It's an open access, so the data sets are for Sentinel are free of charge. And the other is what my Spanish and Italian colleagues and the ones from Austria are doing is applying different types of algorithms that they have developed for nutrient evolution management, for estimating water storage in the soil. So these are more technical aspects which I do not handle, but I'm more happy to put you in contact with those colleagues of mine. Sorry if not being of more help in answering the question.
Thank you very much for answering.
So I will put my chat here.
Thanks, Yuval. Okay, do we have any other questions?
Hello, yes, I do have one more question. Thank you for your presentation. So my question is that, how do you define low impact agriculture in your research?
Oh, that was a good one. We were trying to fit a nice name so that an acronyms with some sense came up. So would be a low impact would be one that minimizes harm to the environment in simple terms. And why you minimize the harm to the environment, the low impact, is because if you can use fertilizers in a more efficient way, or say not as a blanket, but where you really need, as I say, there is less chances that might pollute water resources. Although some people say, well, in the areas where you work, if they are rain-fed, that's not much of an issue, but still goes around the concept of being more efficient in the use of fertilizers. And the low impact would be also in terms of irrigation efficiencies, where you really try to take decisions that can return more or can save more water for the environment, because this is the other big conflict within the Murray-Darling between irrigators and the access to water for the life to maintain the life of the ecosystems within the Murray-Darling basin. So from that, I would say this is what I could say what defines the low impact agriculture. Although there are many definitions, Lydia, and if you are working in precision agriculture, they might tell you, oh, that what I told you is not the definition of low impact, but this is the one that we're adopting in the project.
All right, thank you.
Thanks, Lydia. Were there any other questions? We're just about toward the end of our time anyway, so we might draw to a close. So thank you so much for such an interesting and thought-provoking talk. It was really excellent. I really appreciate that. Thank you.
My pleasure, and I do hope that you enjoyed, and I put in my chat my email address. So if any of you is interested more on the technical details, as Subal was asking, by all means, email me and I put you in contact with those that know better than me about all the technical side of the algorithms and all the some of the products that we are developing. And thank you, Melanie, for organizing these talks. I think it's important that women in earth science connect with other women in earth science. We are not as many.
That's certainly true, especially the women professors. But yeah, no, great. It was great to hear from you. Thank you.
Thank you. Have a good afternoon, everybody. Thank you for the invite.
Bye.
Thank you.
Thank you.